So I built a game with React recently, honestly just to try it out, just to see if it was even possible, if React could do something like this, and it actually worked. I have a game that, although it's super simple, it's bare bones, it actually works and it's fully 3D. It's like a 3D game with a game engine, and React is driving the entire thing. And in this video, I want to share the code with you because although this is a game, although this is like fully 3D and like actually a game engine, everything that I have inside of the application are React components. We're using libraries that are made for React and we're writing React code. And there's a lot of cool stuff in there that you can actually learn from, even though this is a game. And the fact that it's a game just honestly makes it super interesting. So let's get to it. And by the way, if you want to learn React by building a big project as a total beginner, check out Project React in the description. You won't regret it. All right, so let me come here and let me open up the game so you can actually see what I built. We're gonna go to localhost 5173. This is a Vite application, and this is what the game looks like. I know it's super beautiful, it's super amazing, and I can just feel you wanting to play this game right now. This is basically what I have so far. Again, I just did this to try this out, to just explore a little bit because honestly I was bored, but this is what I managed to come up with in like a week's worth of work. So we have all of these characters here which look a little bit eerie, that they're not doing anything and really moving, and then you have your main character over here, and you can click anywhere on the world and your character is going to animate walking, and it's just going to walk. As you can see here, I can actually right click any character and I can press attack or examine. If I press examine, we get here a log inside of the game chat, if you will. Here at the bottom, it's a little bit small, but there it is. And if I click attack, theoretically it should have attacked, but I think I broke this at some point and it's clearly not working. But at some point it would kind of attack and just play the attack animation. This is vaguely similar to RuneScape if you've ever played that, because I played that as a child and I wanted to do something similar, and I just wanted to see if React could do this. And honestly, it can, it's working, it's fully functional, and this is super performant as well. I have like, I think 100 characters right now, I think that's what it is, and we're currently running at 144 frames per second, which is basically the refresh rate of my monitor, which means that we're not dropping any frames. This is super performant, and this is React code that is running on the web, rendering 3D using libraries. So let's get into it. So this is what the code looks like for this application. We have the main app component over here, and here on the right we have the actual file explorer with all of the files of the project. And as you can see here, there's a couple of files, but it's nothing too big. Again, I just did this to test it out to see if React could even do this in the first place and how good it would be at doing that. But there's still enough in there that's interesting to look at that you can actually learn something from this code base. So let's begin. Let's start looking at the app component. So this is the main app component. So over here, what we have is we're basically just getting the user. This is hard coded. We're getting the player character ID because we're going to need to know this ID to know which character on the actual game we are currently controlling. Use auth over here, if I remember correctly, is just literally hard coding it. Yeah, we're setting player character ID to 1 because there's no authentication set up for this project. And we're literally calling it inside of this use effect. And we're not rendering anything, as you can see here. If we don't have a player character ID, we're rendering loading. If we do, we're rendering this piece of code over here. This is essentially where the game happens. So we have this canvas component over here, which is coming from React 3 Fiber. So this is the game engine library. It's based on Three.JS, which is a 3D rendering kind of library for JavaScript. And this is the React version of it. It's actually made by the same people that made Zustand, which I'm also using for this project. And essentially you get a couple of components from them that you can use and actually build the game engine with those. So here we have the canvas component, which is required to put anything that is game engine inside of that component. We set some basic props. This is something for performance. This enables shadows, and this just sets a camera with some default position. And then we have the scene where all of our game engine stuff is actually into, and we're going to get to that in just a moment. First, let's look at user interface and then chat box, because these are outside of the canvas. So user interface is actually just normal HTML React components. They're not part of the game engine, and I chose to do this because this is the user interface, things that people click. If I can just remind you, whenever I click on a character, this little thing that pops up, this is actually React code, HTML code that is not part of the game engine. The reason why I chose to do it this way is because React is better at rendering user interfaces than a game engine would. It's much easier to actually render out HTML like this with React and just figure out the position of where I clicked and where to show it than it is to do exactly the same thing inside of a game engine. That's why I did this. So as you can see, we basically have a div here if we have a context menu, and then for every single item, we're just rendering the item, and then we're attaching the onClick event handler. All of this is coming from a Zustand store. So I have use user interface. This is my store for the user interface. And this is a simple store, which basically just allows me to set a context menu and a function to actually set it. And this context menu will basically have a list of items, and each item is going to have a text property of type string, and then an onClick function, which we can actually call whenever that item is clicked. That's it. I can just call this from anywhere in my code, set a context menu, and then if we have one, this is going to be rendered, and that's exactly the functionality that you see. I set a context window, a context menu, it's showing up here, and this component is driving this entire thing. We're doing pretty much the same thing with the chat box. This is also another component, and here we have messages from the game state. So this is another Zustand store. This one, essentially, the game state just has all of the messages. It has the map and a function to add a message. This is not final. I wanted to kind of split this up into a separate store eventually. I didn't get to it. This is how it currently is. But essentially, all of the messages that we have from the actual store, we're just rendering them over here, right? We're doing messages.slice and then rendering all of them. And then we're just doing some key bindings over here to actually listen to the key down event so that I can just press space or enter, I believe, and directly go and start chatting. I think it's if I press enter or space. Yeah, if I press space, this input here is going to be focused and I can say hello, press enter, and it's going to actually send a message over here in the game chat, if you will. And that was kind of my way of doing that. Again, this is not part of the 3D engine of React 3 Fiber. This is pure React code because, again, React is better at user interfaces than doing this in a 3D game engine. Now let's close all of this and let's get to the actual 3D game stuff, because again, although this is a game, this is all React components and we're using React to drive this entire thing. So we have the scene over here. This is the scene component, and here's where we get to do some React magic, right? So first we're getting the characters from the use character store. So if I open this, this is another Zustand store. So already you can see that I kind of created multiple stores for different things in my application, and that's generally how you want to approach this if you're using Zustand or really any other state management library. Put things in different stores and then combine all the different stores and use them where you need them. It's a lot more efficient to do it that way. So the use character store has basically characters here, which is basically an object which has the key, the character's ID as a key, and then the actual character. That way you can just do characters and then give it the ID and you immediately get the character without having to look through an array. And then we have a function to remove a character, pretty self-explanatory, and one to update a character, which basically can get called from anywhere in the code to update a specific character, where we can update, for example, its attributes. We can set its health from 100 to 50, for example, if it takes damage. And you can also update the state of the character. Currently they're defaulted to idle, but this is where I do state like walking when the character should be walking, or attacking when the character should be attacking, and all of the potential other states that I would need in my application. I have them all in this state here in this store, and this update character function can be called from anywhere and will just update every single character at will. That's it. Then we're getting the characters. We're also getting the map from the game state as well. So we saw this already. And then we're also getting the player character ID, again, from use auth. And we're using that to basically know which is our player character ID. So there we go. We have a player controller, which we're passing the player character ID. And then for every single character inside of the characters, we're rendering an NPC controller, which is how I'm able to get all of these characters to show up on the actual map. And then we have the map over here, which is a simple component that basically just renders all of these components right here. So we have mesh, we have plane geometry. These are React 3 Fiber. These are 3D game engine components, which you can directly use inside of React because we are using the React 3 Fiber library. So this is rendering a mesh, which is kind of just like a thing that has colors and materials. We're saying that it has to be a plane, so a 2D plane, not a 3D plane. And then basically we're giving it a material, which is the equivalent of giving it a specific color. That's what this is. Then we have a component that renders out every single map object. So that's like trees and stuff like that. I currently didn't have any, but if I did, they would go in a state. And then based on the state over here from the game state, we would just render every single object using this component. And again, this is a great example of putting things in different components. I have the map component over here, which handles everything that is related to being a map. And then I have this map objects component, which gets its own piece of state and then renders out all of the objects. And then for every single object, actually delegates the rendering and the functionality to another component. Map object controller receives a map object and then does some functionality like add a context menu. So you can right click on an object and add a context menu. All of this is inside of a component. And then the actual rendering, the actual model of the map object is another React component. And again, this one does some React 3 fiber stuff. It basically creates a group over here and then loads a GLTF file, which I actually had to learn for this entire thing. This is a specific file type where you can actually get a 3D model. And actually, fun fact, all of these models here, I actually made them all myself. I had to teach myself how to actually make models. And more importantly, and more painstakingly, how to actually animate walking. Like I did this animation myself, frame by frame, keyframe, and I ported that over into React. And I did that using a GLTF file, which directly integrates with React 3 Fiber. And that's how I'm able to get the actual characters to show up on the screen. Right, so that's the map. We can close this. And then if we look here, we have player controller and then NPC controller. And by the way, all of these I'm skipping because these are super simple. This just sets some lights for the scene, a camera controller, which allows me to control the camera. So like rotate it here and there. I use a component for that. And then a statistics component, which basically renders this top part over here. That's all these components are. And then we have player controller and NPC controller, which are kind of the most important components. So let's look at player controller and see what that looks like. So player controller just receives a character ID, which we give it the actual player character ID. That's how we're able to actually control this using the character ID that we got from the authentication. And then we just have, again, other components, right? This component isn't doing anything itself. It actually uses 3 custom hooks over here, which have a lot of functionality, and then delegates the rendering to other components. So for example, we have character health bar. If character.state.name is attacking, so if the character is attacking, render a health bar over here. And this health bar is basically just figuring out what it actually needs to render the health bar. And then it's rendering some meshes, some geometries to actually have the health bar. That's it. Character splash list is basically when you hit a character and they show damage on them. That's what this is. Again, another component. It actually gets the splashes from the character and then has some logic to actually manage the splashes and make them disappear after a certain time. And then it just renders out the actual splash itself using React 3 Fiber group components as well. Again, separate component. We have the character path, right? Another component, which is basically every time that I click, I don't know if you can see, but there's a little red line here that kind of outlines the path that the character is going to do and it's going to take. I actually had to not implement, but like integrate a pathfinding algorithm to like figure that out so we can avoid obstacles. That is again another component which renders a simple line in 3 Fiber. That's it. And then we have the character model, which actually takes care of rendering the actual 3D model. And again, we have all of these nodes over here, which again, by the way, I did all of these myself and I had to create them, label them, assign them, put them together. It's a whole thing. I don't know if I like it, but I'm happy that I did it because now at least I know how games are typically made, right? And then based off of this, it just has some functions. It basically does some logic to figure out what material to actually use, what animation to set. And then, so this is the material over here, what animation to set, right? And then it just renders out a group again, and then renders out for the character equipment, like common shirt 1, common pants. It renders out other components, and basically you're structuring things in different components, and each component is usually responsible for one single thing, and you're putting these components together to actually get your functionality that you want. And finally, let's look at these hooks, because as I mentioned, they do have a lot of functionality, which is really interesting. So we have use character over here, and this one, all that it does, this is the simplest one of the 3, all that it does is it basically checks if the character's health is less than 0, and if it is, it's going to remove the character. This is coming from the Zustand store, use character store, and it's going to add a message in our use game state in the messages that says that character ID has died, right? This is a simple hook that I can just place on the player controller, and more importantly, I can place it on the NPC controller over here, use character, because the NPC controller and the player controller are basically controlling characters at the end of the day, and the only thing that matters is the character ID, but it's still a character. So I can use the same hook over here, and I can use all of this in the NPC controller and in the player controller, and that's a great way of creating something, extracting it in a reusable place, and then just reusing that functionality on a different character. Because whether it's the player or an NPC, if their health is less than 0, they should die, they should get removed, and we should get this message added in our game state, right? Doesn't matter if it's a player or if it's an NPC, it's the same logic, so it makes sense to put it in a custom hook and then reuse that in both places. And then we have use character move, which essentially handles the actual moving of a character. So moving it from one point on the screen to another point on the screen. And this is where we're using a combination of React and game engine stuff, so React 3 Fiber, to actually make this work. And the way that we're doing it is super, super interesting. So first, we're getting the update character function from the use character store from Zustand as well. Then we're getting the actual data from the actual character because this hook is receiving a character. Every character is going to have a state here that is going to be move to points. This is going to be an array of points that the character is supposed to move in. We're going to be updating these through React. So we're going to be updating through this update character function. We're going to be updating the move to points in React. That is going to cause a re-render as we're usually used to having it in React. But then we have this use frame hook, which comes directly from 3Fiber. And this one is the one that is actually handling the actual physical movement of that character in a 3D world. So this use frame hook works a little bit differently than use effect, but there are some similarities as well. So the things that it has in common with use effect is that the code that is inside of it, it actually runs. But the things that are different is when it actually runs. So use effect is only going to run this code first once initially on mount. And then if there's an optional cleanup function, it's going to run that code once on mount guaranteed, and then it's going to run it every single time that anything in its dependency array changes. And these are basically tied to the React render cycle. So when this changes, it's going to cause a re-render of the React component, and that is going to cause this hook to actually rerun its code. Use frame, on the other hand, doesn't have any dependencies, and this one runs every single frame of the game. So in my case, if I have here 144 frames per second, this code is going to run 144 times per second. This is how this works. This is things that you need in a game engine because you actually need to move the character every single frame, and you cannot wait for a React render cycle to actually do that. That would be hugely unperformant. This bypasses the entire React render cycle and just runs this code once per frame and how many frames per second you are currently using, and that's based on your monitor, your performance, and your actual physical capacities of the computer. Which means that you have to be very careful the types of things that you put inside of here. You can't put state updates inside of a use frame, because if you do that, then every single frame, in my case, again, 144 times per second, you're going to be updating state and you're going to be causing a component to re-render. So you don't do that. Instead, what we do is over here, we're basically in this use character move component, custom hook actually, we're basically checking that first of all, we do have a character and a next move to point. And if we do, we're checking character ref. So again, character ref, every single character here has an actual ref, which gets put, if I can show you here, on the player controller on a character model, and then we have character. Let me see if I can find character ref. There we go. It's being put over here to this group. So we're actually attaching a ref to an element that is getting rendered in our world, in our game engine. And this is what we're actually using to actually move. So we're checking if that position, which comes again from React 3Fiber, that group element, if the distance to the next move to point is greater than 0.1, then we're actually going to move the character. But what is moving the character? Let's open up this function. Again, I've extracted this in a custom function to make it easier and to make it reusable, because I would use this in multiple places. The move character function takes a ref, which is a 3. This comes from Three.JS, right? The React 3Fiber that is basically running it. And we're making it in object 3D. So this is actually an object in a 3D world. And we're giving it a 2 here. This is a position. This is a vector 3. This is a 3-dimensional vector, which basically means it has X, Y, and Z. That's all it means. Then we're giving it a speed and delta. You don't have to know about this. It's whatever. And then we're just getting the direction, and then we're adding that direction to the position of the actual ref. We're doing that every single frame. We're not waiting for React to re-render. We're doing that every single frame. And that is how, whenever I come here and actually click, every single frame, we are moving the position of this character based on the move to points. This specific part is not React, and this part is exactly React 3Fiber that is doing that work for us in the game engine world, because again, it wouldn't make sense, it wouldn't be performant to do that in the React world. There's some things that you only do in the game engine world, and there are other things that you only do in the React world. And the beauty of it is when you combine both of them together and use each one of them for the things that they are good at. And that's it, right? We're just moving the character, we're then rotating the character to actually make it face the direction that it's going to move. And if the distance is not greater than 0.1, then the only thing that we're doing is we're just updating the character state to character state.next state in case that there's a next state. I ideally want to change this, but we would change this to idle, for example, right? Because you've stopped moving, you're in idle. But this only happens once, right? This is very important because we are in the use frame hook, and this one runs every single frame. So we have to be careful about the things that we actually put in here. Right, so that's use character move. We can close this, and now let's quickly look at use character state, because this one does pretty much the same thing, but with the character state. So the character can be in different states. It can be idle, it can be attacking, it can be walking, right? I think walking, I did it in the other hook, but it should have been together. Or I was trying to figure it out, but I didn't find a really clear pattern on how to do this. So I just have the attacking over here. But we're doing the same thing. We have a use frame hook, which basically, again, runs every single frame. And then we're checking if the character state is attacking. We're going to run this code, right? We're going to check the target character, which comes from the character state. We're going to check the distance between the target character. And if the distance is greater, we're actually going to find a path to that character. And then we're going to set that path over here. I think, yes, we're going to update the character. We're going to set its state to walking. We're going to put the move to points that we actually calculated here. And then we're going to make the character walk to the person. So if we're trying to attack the person, the other character, but the other character is too far away, we can't just attack in the void. We're going to first walk to that character, and then we're going to attack. That's what this code is doing. And then if the distance is smaller than 0.1, then what we're going to do is we're going to rotate the character to our target character. So make it actually face the character we want to attack. And then we're going to check when was the last time that we attacked, because we don't want to attack every single frame. That would be unreasonable. We want to make like a delay of like at least 2 seconds, I put it, but this would ideally come based on the character statistics, right? And if it's been less, if it's been more since 2 seconds, then we're actually getting the attack. We're calculating some very simple chance to hit, like if 30% you're going to miss, right? And then if you miss, we're adding a message over here. If or not, we're calculating the damage, which is based on your strength and the target character's defense. And then we're simply updating the target character using Zustand. We're making a state update in Zustand, and we're basically reducing the health of the target character. We're adding some splashes, some damage splashes to the character. And if the target character has auto retaliate, we're basically making it attack and then attack you. Target ID, character ID, that is you. If the target character is supposed to attack back when you attack it, it is going to attack back through this code. And then we're just adding a message on the game log, and we're saying that character hit target character for this amount of damage. And then we're updating the last attack.current. This is a React ref, which basically we all know this is how ref work, because we need to have the access to the up-to-date value inside of this use frame hook, and we can't use state for that. That's why we did this. But pretty much this hook is going to make it so that whenever you attack a character, it is going to attack. Again, it's currently broken. So if I do this, if I right click, as you can see here, we press attack, the distance is greater, so we're actually walking to that person. But when we get there, the code to actually attack and trigger that attack isn't working, so we're just going to stand there and kind of be inside of that character. Again, work in progress, just did this for fun to see if it was even possible, but I'm pretty happy with this. I'm pretty happy with the result that I was able to do, and this is easily extensible. I can add as many characters as I want, I can make them have different items, I can add objects in the world, and I could realistically build a game for this if I wanted to. The question is, do I want to? Honestly, I don't know. I don't think so, at least not this way, but you could. If you wanted to, you could. And there actually are some examples of people that have done this with React and have built some quite sizable games with it. So yeah, guys, that's pretty much it. That's kind of the general overview. There's not that much more to it. Other things are just details, but in a nutshell, you kind of get the idea of how I approached this project, how I approached it. I use React for what it's good at. I use React 3 Fiber for what it's good at. And I combined and I figured out a way to effectively combine the React world with the 3D game engine world and use both of them for what they're good at and make something that actually has a lot of potential, right? So I'm really happy with this. So there you go. If you enjoyed this video, I would really appreciate it if you left this video a big thumbs up. You can also click here to subscribe, or you can click here to watch a different video of mine that YouTube seems to think that you're really going to enjoy. And with that being said, my name has been Darius Kozlan. This is Kozlan Solutions. Thank you so much for watching, and I will see you in the next video. Ciao, ciao.